All right, so let's go to the next question. Don't know why that's there. Let's go ahead and, so it says now, this time they want us to compute the test statistic. So that's the formula that we got to calculate. So Z test. So Z test was X bar minus mu divided by sigma over square root of n. Okay, so in the problem, they said that the claim was that the average was 546, right? And they said that 36 males were selected, so that's going to be my n. They said that the mean of the number of calories is 544.8, and that's for the sample of 36 males. So that's my sample mean. That's my X bar. And then they said that the standard deviation of the population is 3. So that's my lowercase sigma. So going ahead and plugging those values in, we get 544.8 minus 546 divided by 3 over square root of 36. So we're going to do this on the calculator. Let's see what we get. So I get about negative 2.40 for my my test statistic. Now I actually got negative 2.4, but they wanted it to 2 decimal places, so make sure you include that extra 0. So negative 2.40. That's my test statistic. So if I were to label this, I'm going to label this, go back on my graph and label it. So negative 2.40 is actually right here. Right? So that means we are actually not in our rejection region. Remember that the red region that I shaded is the rejection region. Red means rejection. So that means that since we're not in the red region, that means we do not reject the null hypothesis. So we do not reject. So based on the results here, we should fail to reject the null hypothesis. All right, so since we failed to reject, that means we do not have enough evidence. Okay, so we do not have enough evidence to, so for this part, we said that the claim belonged to the null hypothesis, which means that we're going to use the word reject. Remember, if the claim belongs to the HA, we use the word support. So we should say there is not enough evidence at the 1% level of significance to reject the claim. That it's 546 calories per hour playing tennis. Okay. That's it for that question. Number 11. This was a brand new question. A researcher claims that the yearly consumption of soft drinks per person is greater than 52 gallons. In a sample of 50 randomly selected people, the mean of the yearly consumption was 56.3. The standard deviation is 10.2 gallons. Use a 5% significance level. So let's go ahead and write out our claim. So it says the claim was that the yearly consumption of soft drinks is greater than 52, so mu is greater than 52. This means that it's a statement of inequality, so this belongs to the HA. So this is a HA right now. Which means that the HO, the H0, the null hypothesis, is going to be the opposite of that. Okay, so it's going to be less than or equal to. All right. So we have here less than or equal to, and then greater than. For number 12, the claim belongs to the alternative. And what's the direction of the test? Well, that depends on the HA, right? And that's pointing to the right. So that's a right-tailed test. Okay, so right-tailed. Oops. Now we're going to compute the critical value. So again, let's draw out the curve, the standardized distribution. Now we don't know where the critical value is going to be, but we do know that it's a right-tailed test. So let's just say it's somewhere over here. That's my Z crit. The area to the right is given by my alpha. And my alpha is 5% significance. So this is 0.0500. That's my alpha. All right, so remember that we want the Z chart gives us the area to the left. So we want to find this area on the Z chart, which is going to be 1 minus V alpha, which is 0.9500. So we want to look up this area to get the Z crit. So let's go to the Z chart. Okay, so we got 0.9500. Again, it's a tie between 9495, 9505. So it's going to be 1.64 or 1.65. You can choose one. I'm going to choose 1.64. And that will be my Z crit, Z critical. All right. So researcher claims same question, but now they want the test statistic. So let's calculate the test statistic. Now it says we know that the mu is 52 gallons. That's the claim, right? That the consumption of soft drinks is 52. The sample size is 50 people randomly selected. The mean of the sample, which is X bar, is 56.3. The standard deviation of the population, sigma, is 10.2. So we have everything we need to do the calculations. So the test statistic is calculated by X bar minus mu over sigma divided by square root of n. So we have 56.3 minus 52 divided by 10.2 over square root of 50 people. All right, so we're going to go ahead and put this on the calculator, per usual. So we get about 2.98 for my critical, or for my test statistic rather. Okay, so that's my test stat is 2.98 to 2 decimals. So if we label that on here, 2.98 is actually, so this is 1, this is 2, this is 3, 2.98 is actually pretty close to 3. So this is my test statistic is 2.98. Notice that is smack dab in the rejection region. That's in the red region, which means that tells me that I reject. I need to reject the null hypothesis, okay? So therefore, based on the results, we should reject. Okay, so we should conclude that there is enough evidence because we're rejecting. And since the claim belonged to our alternative, we're going to use the word support. So we should conclude that there is enough evidence at the 5% level to support the claim that the average yearly consumption of drinks is greater than 52 gallons. All right, guys, that is it for the practice. I hope that you found this useful, and I'll see you guys, of course, in the next video.